Me?
Yeah, you started this thing.
Okay. Well, we took a aluminum can. We took all the paint surface off of it, cut it into thin metal strips, and each one of these placed different solutions. Like, you want to talk about which solutions we placed in there?
We had water, cola, sodium hydroxide, hydrochloric acid, copper sulfate, and vinegar. And so we just dropped each one of a piece of aluminum each one and observed what was happening. And you know, talk about what we saw happening. We immediately saw some of the sodium hydroxide started bubbling, and a few minutes later the hydrochloric acid started bubbling. And at this point, a few hours later, an hour later, the aluminum has disappeared, and pretty much, and you just have sediment. So copper sulfate has some copper, very little being deposited, and the vinegar, the cola, and of course the water is the control. Right now there's nothing much happening. We'll leave it overnight and see if anything happens. Basically we were testing to begin with the effect of acids and bases on the aluminum of a can, and seeing why they had coatings on the inside of a can. But we also were wondering what type of replacement reactions were going and what gases were being produced. So, tell them what we did with that.
One other thing, after a little while, the sodium hydroxide solution quit dissolving into the aluminum. The aluminum quit dissolving into there. So we got to wondering what was going on there. So we placed another piece in there and did a flame test. But with the flame test, we couldn't determine whether hydrogen or oxygen was being produced. On the next one, the hydrochloric acid, we did a flame test and definitely could tell that hydrogen was being produced because it gave a good pop whenever we put the flame on.
Where's their cap on that? We were trying to capture the gas.
Either hydrogen or oxygen, which one? What we're thinking is we're not collecting enough right here to get really a good test.